Okay, so today we will be solving this problem from the TIFR question paper. So this problem says that if I take any strip bounded by two parallel lines in R2 which has width greater than 1, I mean strictly greater than 1, then it has to contain points. It has to contain a point with integer coordinates. All right. So there are two steps for this problem. It's practically a basic visual, I mean, it's a visualization problem. So as you can see, if I go to the second page, so suppose these two are the parallel lines. Suppose these two were the parallel lines. All right. And the width between them is given to be more than 1. So it is strictly greater than 1. Thus, so the perpendicular distance between them is strictly greater than 1 wherever I actually take this perpendicular. So it's been given that it's strictly greater than 1. All right. So now as you can see, that's so there are two steps as I was mentioning. So one of the step is something like this, that what happens whenever we have only horizontal or vertical strips. All right. So let's just think about horizontal strips which has width more than 1. So this is strictly greater than 1. All right. So now this is one thing that you can visualize, that if you pick any real number and you take +1 or -1, then you are bound to get an integer in between that interval. Okay, because that proof can be quite easily done. If you pick any r, then there always exist, I mean, suppose let's not take any integer r, then there always exist two such integers such that the r falls in between them. All right. So now if you take r plus 1, so then what will happen is an integer will, I mean, there are of course integers that are the closest to r. So we are taking those two integers that are closest to r. All right. So that is m and m plus 1. So if you just take 1, if you just add 1 with r as the width, then one of the integers will actually fall inside there. Okay, it's pretty much very basic properties in real numbers. So now we will use the fact here. So since this width is actually, so let's just call this some r. All right. So at some real number r, it has been taken. So now here, if you take, so and this is, let's say, r prime. Um, Whenever this is I'm taking as r prime, then r prime is strictly greater than r plus 1. So what does that mean? That means they're obviously, so if I take this as the real line, so let's say this is I'm taking as the real line r, and here then it is say r comma 0, and this is r prime comma 0. So in between them there is always a point which is an integer. All right. So then what I will do is that in horizontal stripe I will take this distance, I will take this distance, and I will add it here. So then what will happen? Then what will happen is that I have a point whose coordinates are integers. All right. So the same thing I will do for the horizontal stripes. So these are the vertical stripes. So the same thing can be done for horizontal stripes. So here I have just produced x y. We let's say x comma y, where x comma y they are both in integer. All right. So let's just say z cross z. All right. Okay. So now the same thing can be done in any horizontal stripe as well. The same method that you have is, you pick the horizontal one, there is bound to be an integer in between two real numbers on the y-axis. From there you just take that distance, just like we did here. So from here what we will do, so from here, so now it's practically dealing with now it's practically dealing with stripes of this pattern. Okay, like I mean stripes that have some angle with x or y axis. So it's without loss of generality, you can actually take this one. Now what happens, look closely, that since this is greater than 1, so since this is greater than 1, all right, so this thing is always greater than 1. This distance is always greater than 1. All right, the reason behind is that this is a triangle that has one angle as 90 degrees, so this becomes I mean the hypotenuse. All right, so what happens is that thus let me kind of name these. So let's say A, B, C. So thus the distance, so B minus A, let's just call it, yeah, so here it will be B minus A. This is strictly greater than the distance between A and C, correct? So from here what you can actually see, so from here I can actually draw, I can point C somewhere in between. So in C means I'm just projecting this line here. So I'm just projecting this line here. So I have this distance, and then I'm actually taking the same distance here. So now since this same distance I'm taking and it's greater than 1, I have an integer point in between. So let's call this the integer point m. Okay, so I have an integer point in between. Now what we have just done in the previous slide is that we have proven that any horizontal or vertical stripe will always contain an integer point, right? So then what we will do is we will pick an horizontal stripe like this. So this choice is actually important. So we will pick an horizontal stripe, let's say starts here, ends somewhere here, such that there is it contains an integer in the intersection point of these two stripes. And this choice can be made thoroughly because we have proved that any width greater than 1 horizontal stripe will always contain an integer point. All right, so I will choose an horizontal stripe that contains an integer point from 0 to, let's say, this point something. So I can always choose it. All right, so now what happens is that whenever this is in here in this area, I'm choosing the horizontal stripe such that a point is here in the interior. So you pick that point, you draw that point here. So you take y equals to constant line, and then you match with m. So then what happens is that you get something like this, that this is the m, and let's say this is the y equals to some c naught. So it goes like this, and thus there is an integer point interior to the strip bounded by two parallel lines. All right, so what did we do? We first made the conclusion that any horizontal or vertical stripe will have an integer, I mean will have a point with integer coefficients. Thus, the choice of horizontal or vertical stripe that we have is free, and hence we can actually construct an horizontal stripe such that that red line is there. All right, and hence the solution to this true false question is that this is true. Okay, so here is something that is so no matter which type of stripe, which type of strips you choose, it won't matter, because you always have a choice of your horizontal or vertical strips. So which kind of will intersect and will give you the desired point. Okay, so that's it for today's TIFR problem. We will meet with another one in the upcoming session. Thank you for joining.